students, this is notes on dot product. So we did that at the very end of class. I'm just going to go over that briefly, just as a quick review. And then also how to find the angle between the vectors, because we did not have time to go over the formula for that. Okay? So remember that finding the dot product is going to look like this. So it's going to say find v times w, where, and then it's going to give you two vectors, either in ordered pair form or in component form, which is where it has the I and the j with it. We'll do one like that at the very end as an example. So for this, I need to take each x value, right? And I am going to, if you remember, multiply them together and then add the x and the y. So the product of the x's, so I'm going to grab my -2 and my 3, and I'm going to say v times w equals -2 times 3, and then I'm going to add the product of the y's, which is 7 times 4. So I'm going to put 7 times 4. So this is just our dot product. It can also be called inner dot product as well as scalar multiplier, I think. But I'm pretty sure we're going to call it dot product for our 2-day exposure to this. Okay, but that means dot product when you see that. So now just do the math. It's going to be -6 plus 28. And that totals to, good Lord, basic math, sorry, 22. So v times w, or my dot product, for these two vectors is 22. Okay, now from there, I'm going to show you the formula. So to find the angle between two vectors, we're going to use this formula. The things that we need are the magnitude, right, of each vector, which is represented by these double absolute value looking signs, v and w, and then also the dot product, which we just found on the previous page. So I am going to look at this. I'm going to bring that 22 over, and that's going to be my top number there. So let me erase these arrows that I have on here real quick, just so I have a little more space. And then I'm going to pull that 22 from the other side because it's the same ordered pair we're going to be looking at here. So that's going to be 22. And then on the bottom, I got to actually find the magnitude. And you guys remember, I keep saying magnitude is a length and magnitude is the same as the hypotenuse of a triangle. So to find the magnitude, we use the distance formula, or if you want to think of it as Pythagorean theorem, that's fine too. So I need to go back and look at what my ordered pairs were. So my first one was -2, 7. I'm looking at this one right here. So on this page, I just have a little more space. So I'm going to go ahead and find the magnitude of v right here. So remember, we could just go square root, and then we're going to do, right, square our two sides. So we're going to do how long is v. So if you want to think of it visually, you guys, I'm going to erase this in a second. But remember, like, here's my axis. -2 would go this way 2, and 7 would go up 7, right? So it would look something, whoops, like this for my vector, right? So what I'm trying to find when I do magnitude is the length of that by dropping in a right triangle right here, yeah? And so I'm just doing, right, 2 squared plus 7 squared, and then taking the square root, which is going to find the magnitude, which is located right here on the hypotenuse. Okay, so hopefully that visual helps. I am going to now erase that. So if you want to pause it so you can get that drawn, then go ahead. All right. So I just am limited on my space here. Sorry, guys. So from here, I just do the math, and I end up getting, let me change my color. What is that? 4 plus 49. So square root 4 plus 49 is 53, trying to make sure I don't make a silly mistake here. So square root of 53 is my magnitude of v. So I'm going to go over here, and I'm going to put that in right here on the bottom, square root of 53. And then I'm going to be multiplying that times whatever my magnitude of w is, okay? So let me go back to this slide, and now we're going to do the same thing with our w here. So I'm going to find the magnitude of w. I'm not going to draw the picture this time if you need to do so. But guys, hopefully you see this is 3 and 4. So that is our 3, 4, 5 right triangle, right? So hopefully you won't even have to do the formula, but I'm gonna do it just to make sure I don't lose you. So one side is 3, one side is 4. When I square them, I get 9 plus 16, which is 25, and the square root of 25 is 5. So that's just that special, or not special, right? The Pythagorean triple 3, 4, 5 that keeps coming up. So that's just going to be times 5. And then I have cosine theta over here all by itself, right? So I want to rewrite that. And instead of cosine theta, guys, how do we find theta? How do we undo the cosine, right? We do the inverse cosine, not the reciprocal, so we don't want to do secant or 1 over cosine. We want to actually do the inverse. So I'm going to write inverse cosine of, and then I'm just going to type all this in, and it's probably going to give me a decimal. Now here's where I don't think it specifies on the homework whether we want the angle in radians or degrees. So I would say it's your choice. I'm probably going to go ahead and do both just so that it is good. And then you can see both for now, okay? One thing I would caution you about, I'm going to rearrange this bottom denominator part because I feel like it is, sometimes you might make a mistake if you put the 5 after this root 53 because you might accidentally put the 5 under there and then that's a totally different number. So I'm going to rewrite it like that just so we don't make any calculation errors. You're going to plug this whole thing on your calculator. If you're in radian mode, you're going to get that theta is approximately, I should do a squiggly sign, 0.922 radians, and that's okay that it's not in a pretty, pi over something. No big deal because this is, most of them are not going to be our special angles. If you get degrees, if your calculator's in degrees, you're going to get approximately 52.8 degrees. And nearest tenth of a degree is perfectly fine for this. Okay, so that is how you find the angles. So this formula right here is very important, and you need to write that down and box it and highlight it and say that is what we need to find the angle between two vectors, okay? So I'm going to do one from your homework because I'm just super nice like that. So here we are. We're at 10.1.4. This is 2C, which is actually, I'm looking at it right now, you already calculated the dot product for 1A, if you have done that problem already. So 1A on 10.1.4, right, has the dot product, or 1C, I'm sorry, crazy. 1C has the dot product for this, but, so I'm going to go ahead and put that on here for you since hopefully you've already done that part. So the dot product is negative 15. Now remember right here, guys, these are in component form with i's and j's. So first you have to change them to ordered pair form. Unless you're just really good about looking at the numbers, you might not need to write it in ordered pair form, but it makes me feel better. So I write them as ordered pairs first. Then I do the dot product, which is multiplying, right, these x's right here, and then multiplying the y's right here, right? And then adding them together, and that gives me negative 15. So then I'm going to use that. Let me go back for you. Here is the formula we need right here, and I'm going to use that formula. So it's cosine theta, sorry about the pauses, equals, and let's just double check it one more time, dot product, which I just got, so I'm not going to write a times b. I'm going to go ahead and put my negative 15 in. And then remember, it's divided by the magnitude of each one. So I need to find the magnitude of a and the magnitude of b. So I'm going to do that right now in red. So here is my a, right? To find the magnitude of that one, I'm going to do square root of 6 squared, always put that in parentheses just to be safe, plus negative 1 squared. So that is 36 plus 1, which is square root of 37. So that's going to go right up here in my denominator. And I'm going to multiply that times whatever my magnitude of b is. I'm going to do that one in this nice purple color. So here's my b, negative 2, 3, which I got from right up here, guys, right? From this component form. So negative 2, 3, I'm going to do the same thing. I'm going to find its magnitude. So the length of the hypotenuse, if I was going to draw it, would be negative 2 squared plus 3 squared. And that is what? 4 plus 9, which is 13. So square root of 13. All right, so this time I don't have anything pretty, but you don't even have to worry about it, guys, because you're putting it on a calculator, right? So now I want to use the inverse sine, or cosine, sorry, not sine, inverse cosine. So I'm going to do cosine negative 1 is what I want to do, right? So I'm going to go cosine negative 1, or arc cosine if you prefer saying it like that. And then I'm going to just grab this whole thing. I'm just going to write it in black to save time. Over, I don't even need to multiply these together. My handy calculator is going to do all of that for me. Right, and that will give me my answer. My theta in radians comes out to approximately 2.32. Let's go with 2.32 radians, right? And in degrees, my answer comes out to approximately, I'm getting 133.15, so I'm just going to round it to 133.2 degrees. So those are my two approximate theta values, both radians and degrees, for that vector, the angle that would fall between that vector. I hope that helps, guys. Tomorrow we'll do some practice. Thanks.